Welcome, everyone. Today, we are diving into a fundamental aspect of Azure security and management, Azure Role-Based Access Control, or RBAC. Specifically, we will focus heavily on how and why we assign roles at different administrative scopes. Let's get started. Let's begin by defining what Azure RBAC actually is. Looking at our first bullet, Azure Role-Based Access Control is Microsoft's authorization system for managing access to your Azure resources. The basics are simple. It defines who can do what to which resources. Why do we use it? Well, it's essential for security and compliance, allowing you to segregate duties rather than giving everyone global admin rights. How does it function? It works by creating what we call a role assignment. As we dive deeper, remember that Azure RBC operates specifically on the Azure Resource Manager, or ARM, management plane. This means it controls management actions like deploying a virtual machine or deleting a storage account. Let's look at this diagram to visualize the flow. On the left, we have our identity, which could be a user or an application. When they request access to an Azure environment, that request passes directly through the Azure RBAC system. RBAC acts as the gatekeeper, evaluating the authorization roles. If the role assignment permits the action, access is granted, and the user can manage the Azure resources. If not, the request hits a wall and access is denied. It's a clean, centralized security checkpoint for your cloud infrastructure. Moving on to our second topic, we need to break down the concept of a role assignment. What is it? It's the actual configuration that binds access together. To make a role assignment, you need three pillars. First, the who, known as the security principal. This could be an individual user, an Entra ID group, or even an application's managed identity. Second is the what, or the role definition. This is your list of permissions, like the built-in reader or contributor roles. The third pillar and the main focus of our training is the where, the scope. Deep down, if you are missing any of these three pillars, you cannot grant access. It's the unique combination of who, what, and where that creates a secure Azure environment. This diagram beautifully illustrates the recipe for access. At the top, we have our three ingredients, the security principle representing who, the role definition representing what they can do, and the scope representing where they can do it. All three of these components converge into the central node, the role assignment. Only when these three elements are bound together is the final outcome achieved, which is granting targeted access to Azure resources at the bottom. Now, let's zoom in heavily on scope. What is a scope? It defines the precise boundary where your role assignment is valid. Azure structures scope in a strict four-level hierarchy. Level 1, at the very top, is management groups. These are massive containers used to manage multiple subscriptions at once. Level 2 is the subscription itself, which acts as a billing and primary management boundary. Below that, Level 3 gives us resource groups, which are logical folders holding related resources for a specific project or application. Finally, at Level 4, we have the individual resources themselves, like a single database or virtual machine. You can assign a role at any one of these four levels. Take a look at this hierarchical tree. It perfectly represents Azure's management architecture. At the top, you have the management group, branching down into multiple subscriptions. Inside subscription 1, we see it further splits into resource groups A and B. Finally, resource group A contains individual resources, like a virtual machine and a storage account. If you assign a role, you must pick exactly which box or node on this tree that role applies to. The higher up you go, the broader the access. Why do we care so much about which scope we select? Because choosing the correct scope is how we enforce the principle of least privilege. The basics of this principle state that users should only have the absolute minimum access required to do their daily tasks. By thoughtfully selecting scopes, you mitigate risk. If you assign broad access at the subscription level, you increase the blast radius if that user's account is ever compromised. By using targeted scopes like the resource group or resource level, you protect other workloads. In a deep dive scenario, an app developer building a website should be granted contributor access only to the specific resource group containing their web app, ensuring they can't accidentally delete networking infrastructure in a different resource group. This block diagram highlights the risk profile associated with scope selection. At the top, we see the broad scope, representing a subscription-level assignment. This is marked as high risk because any permissions granted here cascade down to everything. Below, we see two narrow scopes, representing resource groups A and B. These are marked as low risk because assigning access directly to Resource Group A isolates that access, completely protecting Resource Group B from any accidental changes or breaches. Now we must address one of the most critical concepts in Azure Access, role inheritance. What is it? Inheritance dictates how permissions flow downward through the Azure scope hierarchy. The basic rule is that a role assigned at a parent scope is automatically and implicitly inherited by all child scopes. For example, if you assign a user the reader role at the subscription scope, they can read every single resource group and resource inside that subscription. A key management concept: you cannot explicitly block or turn off standard RBAC inheritance at a lower level. For our deep dive, this means to prevent unintended access, you must assign roles at the lowest possible scope. The only way to stop inherited access is by using strict deny assignments, typically deployed via Azure blueprints or deployment stacks. Let's follow the flow of inheritance in this diagram. At the very top, a user is explicitly assigned the reader role at the subscription level. Notice how the arrows push that permission downward. Resource Group 1 and Resource Group 2 both automatically inherit that reader status. The inheritance continues to flow down even further, directly into individual resources A and B. The user never needed a direct assignment on resource A. The top-down inheritance provided it automatically. What happens when a user gets assigned multiple roles at different scopes? Azure resolves this using the additive model. The basics are that Azure RBAC is strictly additive if a user has overlapping roles. The most privileged access rights always take precedence. Let's look at an example. Suppose a user inherits a reader role from the subscription scope, but you explicitly grant them contributor on a specific resource group. The result: the permissions add together. The user will have full contributor rights on that one resource group, while remaining a reader on the rest of the subscription. Taking a deep dive, it's vital to remember there is no standard deny role in Azure RBAC. Azure just piles all granted permissions together to determine your effective access. This flowchart demystifies the additive model. On the top left, we have a user who has inherited reader access from the subscription. On the bottom left, the same user is explicitly given contributor access on a specific resource group. Both of these assignments feed into Azure's effective access engine. Because permissions combine additively, the output on the right shows the user operates as a contributor on that specific resource group, while safely remaining a reader everywhere else. Now that we know the theory, how do we actually assign these roles at different scopes? We have several robust tools. In the Azure portal, it is a visual process. You simply navigate to your target scope, let's say, a resource group, click on the access control, IAM, Blade, and hit Add Role Assignment. If you prefer scripting, in PowerShell you use the new AZ role assignment, complete, carefully passing the exact scope, role name, and the object ID of the user. For Azure CLI, it's AZ role assignment create. As a deep dive into enterprise automation, you can declare role assignments directly inside ARM templates or bicep files. This means your infrastructure as code pipeline deploys the virtual network and immediately applies the exact scoped security permissions simultaneously. This flowchart outlines the standard operational process when using the Azure portal. You always start at the top by identifying and navigating to your target scope. From there, you open the access control, or IAM, Blade. You select Add Role Assignment, which prompts you to choose the specific role definition, like contributor. Next, you select your security principal, finding the exact user or group. Finally, you review the details and click Assign, instantly applying the permissions to that scope. Let's wrap up with a real-world architecture scenario, putting best practices into action. Imagine you need to maintain centralized oversight for IT, but enable decentralized, agile development for app teams. First rule: always assign roles to intra-security groups, avoid direct user assignments. This makes onboarding and offboarding painless. Next, apply your scopes strategically. Assign your IT audit group the reader role at the highest top-level scope, like the management group or subscription. This gives them inherited visibility everywhere. Then, for your developers, assign the app owners group the owner or contributor role strictly at the resource level scope of their specific project. Deep dive result: auditors can see everything without breaking anything, and developers have total control over their app, with zero risk of them modifying the broader network infrastructure. That is the power of scoping. Our final diagram illustrates this best practice architecture perfectly. Notice the subscription scope box at the top. The IT audit group is granted the reader role here, meaning their read access blankets the entire environment. Below, in the resource group scope, The environment is split. Finance app owners are granted contributor rights securely isolated to the Finance App Resource Group. Likewise, web app owners are restricted solely to the Web App Resource Group. It is a highly secure, perfectly scoped Azure environment. Thank you for joining this session.